All right. Hello, everyone. This is a test review for the first test coming up in our AIM course with Professor Steele. So, I'm going to start with some questions that were requested, and then I have several other questions that I suspect students might have trouble with. But if there's anything I don't go over that you don't understand, please reach out before the test on Monday. So let's look at number 8 here. 5x to the 7th y cubed times 4x to the 5th y. And we can think about this as y to the first. So students are, this looks similar to foiling. You know, foiling is something like 2x plus 3 times x minus 3, where we have two binomials separated by plus or minus signs. Here, there's no plus or minus sign separating this. This is a single term times a single term. So, we're just going to multiply these. And we do multiply the 5 times the 4. We multiply the coefficients to get 20. And we can take this off to the side, as always. X to the 7th times x to the 5th. That's what we see here. Our base stays the same, and this is where we add the exponents. So 5 and 7 gives us x to the 12th. Y cubed times y. This is y times itself 3 times y again, add the exponents, and we get y to the 4th. And so we'll do the same thing on number 9. Again, we take our coefficients and multiply them. And then we're multiplying x to the 8th times x to the 5th, but that's where we add the exponents. That's part of multiplying. Students will sometimes get the process confused and perhaps add 3 and 7 just like they're adding the exponents. But we're just multiplying this term times this term. So take the pieces off to the side if you need to think about it like that. Y times y to the 6th is y to the 7th. So for number 16, we have this fraction here, x over y to the 5th raised to the 3rd power, and then this is being multiplied to 7x to the 7th y cubed. So first we can kind of simplify this and break this down. This is where we have an exponent raised to another power, a power raised to another power. That's where you multiply the exponents. So in this fraction here, x to the 1st raised to the 3rd power, 1 times 3 is x cubed. A power raised to another power is where we multiply. You can think about it like distributing that exponent. 5 times 3 is y to the 15th. So now we take this and we need to multiply it to this term right here, 7x to the 7th y cubed. And this is where I say you might as well think about it as a fraction, because our first term is a fraction. But you have to know that you're just multiplying this to the numerator. We can take any term and put it over 1, and now we're just multiplying fractions. So we're going to go top times the top, and bottom times the bottom. So I'll break this down a bit. Our coefficient on top is 7, and then I have x cubed times x to the 7th times this y cubed. On bottom, we just have y to the 15th times 1 is just y to the 15th. And so we can clean this up a bit because we need to combine our x's in the numerator. And then we're dividing here with our y cubed over y to the 15th. If you got this far, you would get, partial credit, but you need to keep working this down until you cannot reduce any further. So the 7 just stays on top. There's nothing to reduce that with, no other coefficient. X cubed times x to the 7th, we add those exponents. And then this is where I say, where do you have more y's, top or bottom? There are 15 y's being multiplied on bottom. And so when we're dividing with the same base, we subtract the exponents. And now there's nothing left to combine, and we're done. For number 17, remember the zero power rule. Anything to the power of 0 is just 1. And, we can explore that as x squared divided by x squared. When we divide, we subtract the exponents. 2 minus 2 is 0. Anything to the power of 0 is 1. And if we think about this at the beginning, we know that anything divided by itself is 1. So number 17 is just a zero exponent rule problem. And it's 1 because everything is in parentheses. The kind of tricky version of the zero exponent property, a question involving it, would be to say simplify this. And now it's not like if it were 15x all in parentheses raised to the power of 0, that's definitely just 1. But here the 15 is not in parentheses. So this is like 15 to the power of 1, which is 15, times x to the power of 0, which is 1. So that would be 15. So again, you could see either version of the zero exponent rule asked on the test. Moving on, let me move the camera down. Number 33. Again, students will think this is like a foiling problem, but we have a binomial in the parentheses because it's separated with this minus sign. And then we are multiplying. This is one term right here. Negative 8x to the 4th y. It's a negative term. And so we're going to multiply this to both terms in the parenthesis. You can take these and do them one at a time. I know some of you might be able to just do this in your head, but I'll take these one at a time. For the first one here, I'm going to take negative 8x to the 4th y and multiply it to 5xy cubed. So that becomes negative 8 times 5 is negative 40. X to the 4th times x to the 1st. We add those exponents to get x to the 5th. y to the first times y cubed is y to the fourth. And then we have to take this negative 8x to the fourth, y, and multiply it to negative 7y. And the sign between this term and what we get here will be either positive or negative. Here, it's a negative times a negative, so that makes a positive. So negative 8 times negative 7 is positive 56. X to the fourth, there's no x over here as part of the negative 7y, so it just remains as x to the fourth. But then y times y is y squared. And again, here we're multiplying. Don't factor, just stop here. These are not like terms. In order for terms to be like, they have to have the same exponent on each variable. And we do not have the same exponent on our variables. So don't try to combine negative 40 and 56. Just stop there. And we will do the same thing on 34. Of course, you could pause this and work it out yourself. Make sure you understand it. So here, we'll just kind of do it in our head, because I think some students might do it that way. But negative 2 times 6 is negative 12. X cubed times x is x to the fourth. Y times y to the seventh is y to the eighth. Be careful with your signs, because I will take off points if your signs are wrong, because we're taking this negative along with us as we distribute. So negative 2x cubed y times negative 4y, we get a plus, because that's a negative times a negative. The coefficient of 2 times the coefficient of 4 becomes 8. X cubed, there's no x over here. And then y times y again is y squared. And we would stop right there. So here are some other questions from the review that I'd like to go over. Let's start with number 23. X squared x to the seventh, x squared y over x to the seventh y to the negative third. Again, we can have no negative exponents. So any piece of our term that has a negative exponent needs to move across the fraction bar. So what do we have now? I've got my x squared y that was already up top. Now I've moved y to the third up top. Make sure that you change the exponent to positive as you move it over the fraction bar. And then on bottom is x to the seventh. So we'll clean this up a bit. I'll go up here. I have x squared y to the fourth over x to the seventh, because y times y cubed gives us y to the fourth. And now all we need to do is simplify this x squared over x to the seventh. And this is where I like to say, where do you have more x's, on top or bottom? If it's on bottom, put your base on bottom, and then we just subtract to get x to the fifth, and the only thing left on top is y to the fourth. A question like number 27 is frequently missed, and usually the problem is that students only change the sign on the first term. So here we are subtracting polynomials. If it's adding, then we don't change any signs. We just start to combine like terms. But here I can carry down my first binomial. There's no negative in front of it. That's going to change their signs. But I am distributing. You can think about it as a -1 or just the negative, or perhaps just to change all of the signs. But a negative times a -3x squared becomes positive 3x squared. If you think about it as -1, -1 times -3x becomes positive 3x. And a -1 times 5 becomes -5. So really what happens is all of the signs change. And then we can combine like terms. Now, a mistake that I just notice students making on a test like this is they start to combine their confuse exponent rules for combining like terms. X plus x is 2x. You just combine the coefficients. So 7x squared plus 3x squared is 10x squared. You just combine the coefficients and the variable stays the same. You do not add the exponents. We're not multiplying. -11x plus 3x, we just combine the coefficients. -11 plus 3 is -8. So that's -8x. And there's no other constant, nothing that's just a number to combine with that -5. So that just carries down. So we'll turn the page. The problem like 40A on the review. Some students are just going to square the 6x and square the -5. But when we have a binomial squared, we need to write it twice. So we are going to FOIL, and this will be our foiling example. 6x minus 5 times 6x minus 5. So first times first, 6x times 6x. 6 times 6 is 36. X times x is x squared. We continue to FOIL by doing outside times outside. 6x times -5 is -30x, which we will also get multiplying inside times inside. -5 times 6x is -30x. And don't forget about the signs. It's -5 times -5, which is a positive 25. And so all we can do now is combine our like terms. Some students think that this cancels out, but it doesn't. -30x minus 30x is -60x. And then we'll just carry down everything else. So there's going to be a lot of factoring problems, and we'll take a look at a couple of different ways that we can factor. But this is kind of a basic one. I'll give you the sign guide, which will be, because we have a negative right there, the only way to get a -21 is to multiply one positive and one negative. So One way to think about this is our A times C, our chart here. 1 times negative 21 is just negative 21. I'm looking for factors of negative 21 with a difference of positive 4. Only a few things make 21. 21 times 1, and 7 times 3. 7 times 3 clearly has the difference of 4, and it's going to be a difference if your C term is negative. Meaning 1 positive, 1 negative, we're looking for a difference. So if the B term is positive, I want my bigger factor to be positive. So it's a positive 7 times a negative 3. And the only way to get x squared is x times x. So that's one way to factor a trinomial. You can also, break up the middle term, and we'll look at an example like that at the end here. But you're also going to have a question like number 42. And here, when we factor, and the directions will say factor, you might be confused because you're thinking about factoring in terms of a trinomial. But sometimes all you can do is take out the GCF. And 6x and this 10, the only factor they have in common is 2. There's 6 times 1, 3 times 2, and then 10 times 1 and 5 times 2. So other than 1, their greatest factor is 2. So you're basically going to divide both terms by 2, but don't forget to put your GCF out front. And whatever we get here will go in the parentheses. 6x divided by 2 is 3x. Negative 10 divided by 2 is negative 5. And we stop here because it told us to factor. You can check your work by distributing the 2. 2 times 3x is 6x. 2 times negative 5 is negative 10. So it works. 44, another GCF problem, except here we have, they both have the variable x in them. So I can factor out a coefficient of 2. That's the biggest factor that 2 and 10 have in common. And then I take out x to the first. I don't want to factor out x to the second power because 10x divided by 2x squared would become 5 over x. We don't want a fraction. So it's the smaller of the shared exponents and the biggest coefficient we can take out. So divide these by 2x. We don't forget to put our 2x GCF out in front. 2x squared divided by 2x is x. 10x divided by 2x, the x's will cancel. 10 divided by 2 is 5. And you could always check your work. 53 is a good one because there's a GCF that we can take out, a GCF of 3. So we had 3x squared minus 75. Both 3 and 75 are divisible by 3, so we take out that GCF. And now we have our GCF out front. 3x squared divided by 3 is x squared. Negative 75 divided by 3 is negative 25. And if you put this as your answer, I would give you some partial credit. But, pardon me, as we move the camera down. But this is a difference of squares. So this is where we'll talk about difference of squares. X squared is a perfect square, meaning I could take the square root and get a single term like x. 25 is a perfect square. I can take the square root of 25 and get 5. So factored completely, we have our GCF and then our difference of squares factored into its binomials. So again, when it's a difference of squares, it's the same thing in both parentheses, but one has a plus sign, one has a minus sign. I take the square root of x squared, which is x, so that goes out in front, just like it's in front in the binomial there. I take the square root of 25, and that's 5. So this problem can be a bit tricky because students get to this step and think that they're done. But this is where we are done. Let's look at a few more, maybe 4 more problems. Number 58. When we see 4 terms, we need to factor by grouping. Where we draw a line through the second and third term, I bring down this sign right here, my third, the sign in front of the third term, and I look for the GCF of each pair. It doesn't matter where you start, which pair. Out of 5x and 25, the GCF is 5. If you need to take this off to the side, do so, like take 5x and divide it by 5, because that's what's going to go in the parenthesis. 25 divided by 5 is 5. So over here, we look for a GCF, 2x cubed and 10x squared. We have a coefficient of 2, and then again, it's the smaller exponent on the shared variable. Take this off to the side if you need to, but 2x cubed divided by 2x squared is just x. 10x squared divided by 2x squared. The x squareds cancel out. 10 divided by 2 is a positive 5. So we have our shared parenthesis that we write once, and the other 2 pieces make up the other binomial. So, factor by grouping, we have to use factor by grouping as part of the A times C method for a problem like 75, where the leading coefficient is greater than 1, and we can't just factor it out. But I want to show that we can also use factor by grouping for a problem like this. So number 70 is kind of a straightforward trinomial where a is just 1, where it's just x squared. But if we use our A times C, factors of negative 18 that combine into negative 7, we know that those factors are 9 and 2 multiplies into 18, has a difference of negative 7. So I know that I'm going to have a negative 9 and a positive 2 because the sign of the middle term gets attached to the bigger factor. But if you want, and some students have success with this, use these factors to just break down the middle term. Negative 7x is negative 9x plus 2x. And then carry down everything else. And now we can just factor this by grouping. So you can use the factor by grouping on any of these trinomials. On the left, out of x squared minus 9x, I can factor out an x, leaving me with x minus 9. I bring down this sign, and out of 2x minus 18, I can factor out a 2. 2x divided by 2 is x. Negative 18 divided by 2 is negative 9. And so we get our x minus 9 times x plus 2. And again, we'll do 75 here. There we go. We have to use our a times c. You can't just give the two factors that make this. If you do, I might ask you to recreate it for us. But here we have a times c. 6 times negative 3 is negative 18. I want factors of negative 18 that combine into negative 7. Now, that's not a great example because that's kind of what we just had. But that's negative 9 and positive 2. So, again, if we're factoring a trinomial where a is greater than 1, we're going to have to split the middle term. So we get a negative 9x plus 2x, bring down the minus 3. You'll get the same thing if you switch these two terms. Now we have 4 terms and we factor by grouping. On the left, 6x squared minus 9x, I can factor out 3x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is negative 3. Now on the right, out of 2x minus 3, again, we bring down this sign, and this is a good explanation of why. If there is nothing, there's no factor out of 2 and negative 3 that they share other than 1. Anything is divisible by 1. 2x divided by 1 is just 2x. Negative 3 divided by 1 is just negative 3. And so our two factors are 2x minus 3 times 3x plus 1. We can look at one more. We didn't look at a trinomial where we factor out a GCF, so let's look at one like that, and then we'll be done. So a question like number 71, I think, is probably about as difficult as questions we'll get on this test. So anytime we're factoring, we should always look for a GCF, and we certainly have one here. All of these terms are divisible by 3, and then we have a shared exponent, a shared variable, so we take the smallest exponent. So divide everything by 3x, and what do we get? The 3's cancel here. X cubed divided by x to the first. We subtract those exponents, and we just have an x squared. 27 divided by 3 is 9. X squared divided by x is just x. 60x divided by 3x is 20. So don't forget to put your GCF out front. I'll have to dock you a point if you don't have your GCF out front. So maybe draw an arrow so you don't forget it. And now here we're factoring this trinomial. And again, I've shown you a few different ways to do it. So whatever you're comfortable with, but the only way to get x squared is x times x. Factors of 20 that combine into positive 9. It's real easy when it's plus plus here. That's just 4 and 5. So again, don't forget your GCF. So if you have any questions and I did not cover them, feel free to reach out. I'll be around this weekend. So good luck on the test, and I'll see you next time.